So we are going to look at bisection method, or it's also called interval halving method, to find the root of an equation f of x equal to 0. We have a question: find the root of an equation x cube minus 2x minus 5 equal to 0, correct to one decimal place. So first of all, what is our goal? We are going to look for some number c such that when we plug it in the function, it gives us, since we have to find a root correct to one decimal place, so f of c should be equal to 0.10. Correct to one decimal place means 10 after decimal, and the second digit could be anything. So that is our goal. We are looking for some number c, which when we plug in the function, it gives us 0.10 and some digit 3. That's the goal. So for this, we will have to fix our calculator up to 2 decimal places. Okay, so what should be the first step? We have the equation here, x cube minus 2x minus 5 equal to 0. So we will write f of x as x cube minus 2x minus 5. So whatever is on another side of 0, that should be your f of x. Now the first step is to find the interval where the root could possibly lie. So to find the interval, this is what we do. We pick the numbers randomly and we find the values of the function on those numbers. So we start with f of 0, gives us 0 cube, minus 2 into 0 minus 5 gives us 0, minus 0 minus 5, which is minus 5, and this minus 5 is negative, so we are putting a sign like this. F of 0 is negative. We find f of 1, which is 1 cube, minus 2 into 1 minus 5, which is minus 6. Again, it is less than 0. So we have f of 0 less than 0 and we have f of 1 less than 0. Can we have the interval composed of 0 and 1? No, this is not the appropriate interval. From the previous video, if you can recall the calculus result, that the root will lie on an interval where on one end of the interval we have the positive value of the function and on another end of the interval we have the negative value, or the other way around. So 0 and 1 don't make up the appropriate interval. So we will find f of 2, and for f of 2 you can see 2 cube minus 2 into 2 minus 5 gives us minus 1, which is again negative. So 0 1 or 1 2 does not make up the right interval. So we will go ahead, find f of 3, and you will see when you use the calculator, f of 3 is 16, which is positive. So we have two numbers. One is f of 2, on which the value of the function is negative, and f of 3, on which the value of the function is positive. We have two opposite signs answers, so we will say the interval is composed of these two numbers. So we have the interval 2 3. That's the right interval, and in this interval the root will lie. Now for bisection method, which is also called the interval halving method, we will start the step 2 by drawing an interval. So on one end of the interval you have the number 2, on another end of the interval you have the number 3. the value of the function at 2 is -1, which is negative, so I'm putting a sign here. Please know that I'm not saying that 2 is negative, I'm saying that f of 2 is negative and f of 3 is 16, so f of 3 is positive. That's the interval, and less than 0 and greater than 0 are the signs of the function values on these two numbers. Now we have to bisect this interval, means we have to halve this interval, so we will denote it by c naught, this half point, and we will find c naught as the average of these two endpoint numbers, which are 2 plus 3. We will halve it. Your calculator is already fixed to 2 decimal places. Use your calculator to find 2 plus 3 by half, gives you 2.5. So C naught is 2.5. Now after finding C naught, find the value of the function f at C naught, means find f of 2.5. Since your function is here f of x equal to x cube minus 2x minus 5, so use this to find the value of f of 2.5, which is 2.5 cube minus 2 into 2.5 minus 5. When you use your calculator, it gives you 5.63 and it is positive. Now see this, we have found f of c naught, which is positive. C naught is 2.5. When we plug 2.5 in the function, we got 5.63, which is positive, so I'm putting the sign here, positive. It is not saying 2.5 is positive, of course it is positive, but this symbol greater than 0 is placed here because f of 2.5, which is 5.63, it is positive. Now please look at this interval, which is halved, which is bisected. So your next interval is 2 to 2.5 is this, or it is 2.5 to 3. So we have to pick the interval. On the ends of that interval, we have to have the opposite function signs. So it turns out it is this interval. So for step 2, the second part, we are now drawing another appropriate interval, which is this one, 2 to 2.5. We are also marking their signs. F of 2 was negative, so again I'm putting this sign. F of 2.5 was positive, I'm putting this sign. And now in this step 2, second part, we will halve this interval, and this time we will find C1. C1 is again the average of two endpoints, which is 2 plus 2.5 divided by 2. When you use your calculator, you will see that this number is 2.25. Every time you halve the interval and you have the number in this case like C1, so for that C1 you will plug it in the function and find its value. So f of 2.25, when you use your calculator, you get 1.89. Now look at this interval. C1 is 2.25 and at this point you have found the value of the function, which is 1.81, and it is positive. So we will also put here the positive sign. Now for this interval again, what is the next best interval? Is it 2 to 2.5 or it is 2.25 to 2.5? We can see that this interval is the appropriate interval because on the ends of this interval we have the opposite function signs. So the next interval is 2.25 along with the positive and negative signs. And now we'll halve this interval. We'll find C2. C2 is 2 plus 2.25. We halve this and we get 2.13. Every time you bisect an interval at a point, you find the value of the function at that point, f of 2.13, which you will see in your calculator. It gives you 0.40, which is positive. So we will look at this interval. F at 2.13 is positive. Okay, so now the question is, should I stop here? F of C2 is 0.40. Remember, our goal is some number C, and after decimal there should be some 0 and another digit. So this is our goal. This is what we are looking for. But in this case, F of C2, we have 0 point but 4. There is no 0. Until unless we have 0 after the decimal, we will continue to pick the intervals and bisect them. So back to this interval. What is the next best part of the interval? So is it 2 to 2.13 or 2.13 to 2.25? So we can see that this is the next best interval because on both ends we have the opposite signs. We will move to fourth step, and the next interval is 2.13 along with the signs. And now we will bisect it by finding C3. C3 is 2 plus 2.13. We'll halve it. And you will see that in calculator you get 2.07. So this is 2.07. Again, every time you bisect an interval, you find the value of the function at that point. We find f of 2.07, and using the calculator we will get minus 0.27. So back to this interval. At 2.07 the functional value was negative, so we are putting the negative sign. Now we will still not stop because at f of C3 we got minus 0 point but not even a single 0. Back to this interval, the next best interval would be now this one, because on both ends of this interval 2.07 and 2.13 we have the opposite signs. So in the next part we will draw the next best interval, which is 2.07 and 2.13 along with the signs. We will bisect it by finding C4. C4 is 2.07 plus 2.13. We'll halve it and we will get 2.10. So this is 2.10. Every time you bisect an interval, you find the value of the function at that point, f of 2.10, and you will see in your calculator it is 0.06. And now I think we should stop, because remember our goal was to find some number C such that you have 0 point and 10, because you had to find the root correct to one decimal place and some digit. This was the goal. So we have found f of 2.10, which is 0.06. So we will say this number 2.10 is the root of the equation f of x equal to x cube minus 2x minus 5 equal to 0, but correct to one decimal place. Meaning that you had to find the root of this equation. So that's what we have done by using the bisection method or interval halving method. So one thing that you have to ensure in bisection method, that you have to fix your calculator up to the right number of decimal places. In this case it was correct to 2 decimal place, but you were looking for only 1 0. And to ensure that the root exists, you have to find an interval. In this case that interval was 2 3, such that on one end the value of the function is negative and on another end the value of the function was positive. So if you are able to find such an interval, then the root will definitely exist in that interval.